Hi there, let's talk about types of statistical studies. So what's the difference between subjects and participants? Statistical studies may vary, but in all cases, the people, animals, or other living things, or even just objects chosen for the sample are known as the subjects of the study. When people are chosen as subjects, they are called participants, because it is unethical to allow people to be part of a study without their knowledge. They must be willing to participate in said study. There are two main types of statistical studies. Observational studies, which are where we simply observe or measure specific characteristics, but we do not influence or modify the characteristics that we're observing. We are just watching what happens. And then there's experiments, where we apply a treatment, or sometimes multiple treatments, and observe its effects on the subjects. This one, we are actually manipulating something. So I'm going to pause the video and try out these problems. We're going to talk about them in class. And when you're ready, push play. So let's talk about variables. A variable is any item or quantity that can vary or take on different values. If you've ever taken an algebra class, you typically used the value x for a variable. Now, variables of interest in a statistical study are the item or quantities that study seeks to measure. If cause and effect is involved, an explanatory variable is a variable that may explain or cause the effect. A response variable is the variable that responds to the changes in the explanatory variable. So the explanatory variable explains what happened to the response variable. Here's an example. In 1962, Dr. T.C. Singh, head of the botany department at India's Annamalai University, experimented with the effects of musical sound on the growth rates of plants. Let's identify and classify the variables. So our variables of interest are the type of music and the growth rate of plants. The explanatory variable is the type of music, and the response variable is the growth rate. What we're trying to say in a cause and effect type of way is that different types of music cause plants to grow at faster or slower rates. Now, when you're talking about observational studies, you can either do a retrospective study or a prospective study. Retrospective studies are observational studies that use data from the past. One of the most notable observational studies that was retrospective has been smoking. Data have been collected over years and years, and because of that, we can finally say that there's a causal relationship between smoking and lung cancer. A prospective study is an observational study designed to collect observations in the future from groups that share a common factor. One prospective study that is currently in progress is the Flint, Michigan water crisis. Once we found out there was an issue, data began to be collected, and we continue to look at that data periodically to see has anything changed or been affected in terms of health and quality from the lead toxicity. Let's talk about experiments. Suppose you wish to see if a supplement truly benefits an athlete. In order to do this, we need to have two groups of participants, those who get the supplement and those who do not. It is important to randomly assign participants to the groups. The group of athletes who receive the supplement is called the treatment group because they receive the treatment being tested. The group of athletes that did not receive the supplement is called the control group. Researchers can be confident that the supplement works if the treatment group's results are significantly better than the control groups. And we will learn how to quantify significantly better in your Introduction to Statistics course. Let's talk about confounding variables. While having control groups helps to ensure that we account for known variables that affect the study, researchers may be unaware or unable to account for other variables. If these unknown variables affect the outcome of a study, they are known as confounding variables. We often think of cause and effect, the independent variable having an effect on the dependent variable, or the explanatory variable having an effect on the response variable. But it might just be a coincidence, and that there's actually a confounding variable that causes change in both. I'm going to pause the video and try these problems out. When you're ready, push play. Let's talk about how to assign treatment and control groups. There are a couple different things we need to keep in mind. First, we should select groups at random. If each participant has an equal chance of being placed into either the treatment or the control group, it is less likely that people in the two groups will differ in some way that will affect the study. So we often do this by flipping a coin or assigning random numbers, but we want to make sure that we have some random selection going on. The next thing we want to worry about is having sufficiently large groups. By having sufficiently large treatment and control groups, we make sure that there are unlikely to be any differences in the groups in a significant way other than the treatment that is assigned. Think about having a small glass of water or a big pool of water and adding a tablespoon of salt to each. That small glass of water is going to definitely taste different with that salt, whereas the giant pool of water probably isn't going to taste very different. So, small effects have big outcomes on small groups. So let's talk about the placebo effect. Oftentimes, the psychology of knowing that you are in a treatment or control group can affect a study. Because of this, we oftentimes will give participants in the control group a placebo, or a fake treatment. The placebo effect refers to when a participant improves simply because they are receiving a useful treatment. If the patient doesn't know they are receiving the actual treatment or the placebo, the study is called blinded or possibly single-blinded. So it has been shown that a treatment's subject's expectations can be as important as the actual treatment. In 2007, McClung and Collins' work, Because I Know It Will, shows an athlete thinking that they had taken a performance-enhancing drug resulted in performances almost as good as the actual drug itself. They also showed that the athletes who took the drug without knowing showed no significant increase in performance. So this goes to show that the placebo has that psychological effect, very similar to possibly even having the actual drug. So the experimenter effect is when a person conducting the experiment can also influence the results. Suppose that a physician is interested in knowing if a cancer treatment influences a patient's mood. If the physician knows that the patient is in a treatment group, the physician may inadvertently have a more positive attitude during the appointments, causing the patient to be more upbeat. This would make it look as though the treatment is affecting the mood, while it is really the interaction with the physician. So the best way to avoid having an experimenter effect is if the experimenter does not know who receives the treatment or control. This is known as a double-blind study if neither the participant nor the experimenters know who belong to the treatment and control groups. So now I want you to pause the video and try these problems out. When you're done, you're finished.